Quick, graph y equals the cosine of the quantity x minus pi over 4 by hand 2 different ways. This is part of the family of functions series. You will need paper and straight edge. We suggest you create grids similar to the ones at the right as needed. Press pause as needed anytime during the video. The first way is with the cosine dance. Recall what the graph of the cosine wave looks like and the 5 key points of interest. These key points are affected by the parameters in the equation, and in this one there's only one parameter, a minus pi over 4 inside the argument of the function. So that minus pi over 4 inside the parentheses shifts each point horizontally to the right pi over 4 units. So again, shift right pi over 4. The initial point is at a max 0, 1 normally, but since we're shifting to the right pi over 4, that will now become pi over 4, comma 1. And so we'll plot that. Halfway between 0 and half of a pi is pi over 4, comma 1. The point at the end of one period is normally at 2 pi, comma 1, a max, but we're shifting everything to the right, so add a pi over 4, and so 2 1/4 pi is really 9 pi over 4, comma 1. We'll plot that. Halfway between the maxes is the minimum, normally at pi negative 1, but we have to add pi over 4 to pi, and when we do that, we're getting 5 pi over 4, 1 1/4 pi, and we'll plot that one, negative 1. You can see it's halfway between those two. Halfway between the max and the min is our first point of inflection, normally at pi over 2, comma 0, but again, shifting to the right. 2 pi over 4 plus 1 more pi over 4 is 3 pi over 4, comma 0. So there's our point of inflection. You had to see it's halfway between, and the next one's going to be halfway between, but let's look at it numerically. 3 pi over 2, add pi over 4, so that would be 6/4 pi over 4 plus 1/4 makes 7/4 pi, comma 0, point of inflection. Pause is needed to get caught up here. Connect the points as a cosine wave, concave down, concave up, concave down. This is one period of the cosine wave. Let's duplicate it in the negative direction by going back a full period from each point of interest. So going back 2 pi will be at that max. Point of inflection backs up 2 pi, the minimum backs up 2 pi, and the second point of inflection backs up 2 pi. Connect again as a cosine wave, concave down, smile, concave up, frown, concave down. We'll compare to the parent function, and you can see that from blue to green, every single point is shifted to the right horizontally, pi over 4 units. Every single point. We say that the green curve has a phase shift of pi over 4 to the right. That's a key phrase there, phase shift. Pause is needed. So the second way is using a table. So we'll start off with our normal cosine table with the values on the axes. So pause to complete the table. And these are axes values here. We do need to create a second table in green for the one that we actually want. And again, the parameter says we need to add pi over 4 to each x value. That's what happens here when you subtract pi over 4 from x inside the argument. So 0 plus pi over 4 is pi over 4. We keep the y values the same. They're not affected at all by this one parameter, and we'll plot pi over 4, comma 1. Pi over 2 plus pi over 4, that's 2/4 plus 1/4 makes 3/4 pi, and that would be keeping the y coordinate the same, 0. So 3/4 pi, 0, we'll plot that. Pi plus pi over 4, 4/4 plus 1/4 is 5/4 pi. Y coordinate stays the same, and we plot that one. 3 pi over 2 is really 6/4 pi, plus 1/4 pi is 7/4 pi, comma 0. And 2 pi plus another quarter would be 8/4 plus 1/4, or 9/4 pi, comma 1. And that gets our second maximum point. Connect the points as a cosine wave. Frown, smile, frown. And we can plot another period to the left by going back 2 pi from each of the points of interest. And then we can connect as another cosine wave. Comparing to the cosine parent function, we can see again from blue to green, every point is shifted to the right pi over 4 units, a phase shift of pi over 4. Now you try one. Graph y equals the cosine of the quantity x minus pi over 3. Use either method or both for the practice. And we suggest you mark every pi over 3 off along on the x-axis. Pause is needed. Resume when you're ready. And here's the answer in green. And you can see compared to the parent function in blue, every single point is shifted to the right pi over 3. We see it's a phase shift right pi over 3.